Hello, welcome to the course PHY5 B06 Computational Physics. The contents of today's lecture is taken from Core Python Programming by R. Nageswar Rao. We will continue to discuss topics from Module 2, NumPy and Matplotlib. In the last class, we discussed about arrays. In today's lecture, let's get familiarized with another data type known as matrices. And matrices are very similar to arrays, just that NumPy matrices are strictly two-dimensional, whereas arrays are more generic, they are n-dimensional. So you can perform a lot of arithmetic operations using arrays like addition, subtraction, multiplication, etc. But if you want to perform matrix specific operations like matrix multiplications, inverse, etc., then you need to define the data in matrix format only. Let's now see how to create the matrix data type. So once again, you need to first import the NumPy module. Then you need to use a function called matrix. Okay. So suppose I want to create a 3 by 2 matrix with elements 1, 2, 3 and 4, 5, 6. This is the syntax. So instead of matrix, you can also write the function as just mat. That also will work. Okay, so m equal to matrix inside a pair of normal brackets. You define the elements. So you can use normal brackets or square bracket separated by a comma. So first you define the first row, then you define the second row. Okay. So when you print, this is how the data is going to appear. This is very similar to array, right? So instead of matrix function, if you use the array function and print the data, you are going to get exactly the same thing. Okay. Now you can convert an array into matrix. So first you create an array. So here I am going to create a 3 by 2 array with elements 1, 2, 3 and 4, 5, 6. And when I say m equal to mat A, the array A is converted into matrix M. Similarly, you can create a matrix first, then convert that into an array. So arrays and matrices, they both are interconvertible. Another method is to create a matrix using a string. So here, first you define a string with elements 1, 2, 3, 4, 5, 6. Since this is a string, the elements are defined inside a pair of quotation marks. Then you are going to specify elements row wise, and each row is separated by a semicolon. Okay. Now you can convert this into a matrix using the matrix function m equal to matrix str. So the string str is now converted into matrix m. So here you get a 3 by 2 matrix. You can make this program simpler. Here I have done the program in 2 steps. So you can combine these two into a single step. So you can write m equal to matrix inside a pair of normal bracket, then you define the string. Okay, so in one shot you can create the matrix M here. So once you create a matrix, you can perform certain arithmetic operations like matrix multiplication, transpose, cross product, inverse, inner product, trace, etc. So in today's lecture, we are going to specifically discuss about matrix multiplication, transpose and inverse. So the other operations you can read on your own. First, matrix multiplication. I hope you know the thumb rule about matrix multiplication, right? If you want to multiply two matrices, the thumb rule is that the number of columns on the first matrix should be equal to number of rows on the second matrix. Right? Okay. So here I am going to first create two matrices A and B. So first I import the NumPy module. Then I create A with elements 1, 2, 3, 4, 5, 6. Then I create matrix B with elements 11, 12, 13, 14 and 15, 16. So when I print A, this is how A appears. This is a 2 by 3 matrix. And then when I print B, you can see this is a 3 by 2 matrix. So this satisfies the condition, right? Number of columns on the first matrix equal to number of rows on the second matrix. Right? So I'm going to multiply a 2 by 3 matrix with a 3 by 2 matrix, and as you know, the output is going to be a 2 by 2 matrix. You can perform matrix multiplications in different ways. One method is to use the dot function. So when I say print dot a comma b, I get the product of these two matrices. Right? Or you can use the at function. So when you say print a at b, once again matrix multiplication is performed. Or simply you can say print a into b. So this also perform matrix multiplication. You're already familiar with this operation, right? In the case of array, you have seen this operation, but the array operation is slightly different from the matrix operation, because in array, when you say array A multiply array B, basically you're performing an element-wise multiplication. So in that case, the shape or number of rows and columns of each array should be the same. Only then you can perform an element-wise multiplication. But here this is matrix multiplication, so the dimension of both the matrices need not be exactly same. You only need to make sure that the number of columns of the first matrix is equal to number of rows of the second matrix. So the multiplication operation is slightly different in the context of arrays and matrices. In the case of array, we also had a function called multiply. So multiply also performs same element-wise multiplication in the case of array. But here, if you try that function for matrices, you get an error, because for multiply, basically the dimension of both the arrays should be the same, and also it is specifically designed for array data type, not for matrix data type. So you cannot perform matrix multiplication using the multiply function. So keep that in mind. So that about matrix multiplication. Next is transpose. So first let me create an array with elements 1, 2, 3 and 4, 5, 6. This is a 2 by 3 matrix. Now if I want to create matrix B, which is transpose of matrix A, then this is the syntax: B equal to A dot T, where T stands for transpose. So when you print B, this is the result. So you can see a 2 by 3 matrix is now converted into a 3 by 2 matrix. That's a simple transpose operation. Next one is inverse of a matrix. Normally you know how to find the inverse. You first find out the adjoint of the matrix, then divide it with the determinant of the matrix. Right? So here you have an inverse function. So let me first create a 3 by 3 matrix A with elements 6, 1, 1, 4, minus 2, 5, 2, 8, 7. And for finding the inverse, the function name is in stands for inverse, and inverse is a linear algebra function. So to denote that, I have a prefix lin-alg. Lin-alg stands for linear algebra. So when I say B equal to lin-alg dot in A, and when you print B, this is the inverse you obtain. Right? So you can cross check the result. You can first find out the adjoint, then find out the determinant, and find the ratio of these two. You get the same output. So this thing you have to keep in mind. So inverse is a linear algebra function, so always you have to first specify lin-alg, then write in. If you simply say B equal to in A, that doesn't work. You will get an error message. You can also manipulate the elements of a matrix. For example, let me create a 3 by 2 matrix with elements 1, 2, 3 and 4, 5, 6. And I say print A plus 1, basically 1 will be added to each of the elements of the matrix. The output is going to be 2, 3, 4, 5, 6, 7. If I want to change one of the elements of the matrix, for example, I want to change this element 6 into 11. So what is the index of this element? This is A12, right? First row and second column. So I can write A12 equal to A12 plus 5. Now when I print A, this is how the output is going to be. Instead of 6, I have 11. Alternatively, I can also write A12 equal to 11. So in that case also you are going to get the same output. In the last class, we have seen how to input into a two-dimensional array from the keyboard. So you use two loops and you input data one by one. Here is an assignment for you. You need to write a program to read a two-dimensional matrix from the keyboard. Basically, you need to use the same program, and instead of the array function, you need to use the matrix function. So that's for today. In the next class, we will see how to plot data using the matplotlib library. Stay tuned. Thank you.